I'm going to do a formal welcome. All right, everybody, welcome back. I've pressed record, so we are recording session. I thought we could talk about some basic questions from algebra. Now, I know Meng mentioned pinching theorem as well, so if we have time, I'm happy to take questions on that. But let's just start off with some basic vector type questions, okay? So let me share my screen with you and we can have a look at some of the questions. All right, so let me know how things are going, and you know, you can direct me in the chat or you know, however you want to. All right, so these questions are from, I think it's chapter 1 in the algebra notes. Okay, so I'll just start off. You can, you know, feel free to give your comments, your questions, and you know, we can also talk about your questions if you want to do that. Okay, so this is a question from the algebra booklet. It is designed to get you thinking about the algebra of vectors. Okay, so here we've got something where we've got these vectors here. So you've got 3 vectors. I might just zoom in a bit. Okay. Hopefully that's easier to see. So you've got the vector from A to B, the vector from the origin to B, and the vector from the origin to A. And so the question is, how can we simplify that? So what strategies, what might be a first step that you could simplify this problem? Can anyone tell me in the chat? Let me know if you have any suggestions on how we could solve this. This is like a low-level kind of entry problem. So who has a suggestion on how we might simplify this? Let me know. Oh, Manfred, that's an interesting, a very interesting suggestion. So you're saying write AB as OB minus OA. Okay, let's do that. Thanks for your suggestion, Manfred. So you're suggesting a algebraic solution. And so what will happen now is that we'll get a bit of cancellation, right? OB minus OB cancels, and negative OA plus OA. Da, 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 da. So what is the answer? Who can tell me on the chat? Right, Meng, it is the 0 vector. So I'll write that like this. Okay. Thank you, Yuan Hao. Now, another way to do this is the, let's call this the Manfred solution. Okay. Can anyone suggest another way of simplifying that expression? Let me know in the chat if you can think of another way to solve it. Right, Yuan Hao, sum up OB and OA. Right, so instead of working with this, we work with these 2 terms. And what are we going to get? Negative AB. So that's another algebraic way of doing it, right? Thanks, Yuan Hao. What about another way? Is there another way to do this problem that's not algebraic? Who can tell me? Is there a third way to do this problem that's not algebraic? Oh, man, yeah. That's what I was thinking. Using a vector diagram. Excellent. So really here we've got 3 points. We've got the point A, the point B, and the origin. Okay, so I'm just going to draw these in sort of arbitrarily. I don't really care where they go. And we want the vector from A to B. Look, we want the vector OA. Look. And then we want the vector negative OB. So that's the same as the vector BO. Okay? So if we start here, right? OA plus AB, zoom, zoom, minus OB, bring us back to the origin. Okay? There. That's it. So there are an algebraic solution, Manfred solution, right? And of course, you can work with this instead of that. That's the Yuan Hao solution. And then the diagram solution. Okay, so pretty easy, right? Pretty easy. This is usually the fastest, but it's good to know this as well. Okay, so let's do a slightly more challenging one that also involves pictures. So I thought we could talk about question 4. So question 4 involves some triangles. So you have 3 points, A, B, and C. You can form a triangle, and then you have some extra points, which are the midpoints of the 2 sides. So that length and that length are equal, that length and that length are equal. Okay? And what they're asking you to do here is to show that this line MP is half the length AC, right? So MP is parallel to AC and it's half the length, all right? So really what they're asking us here is to show that this equals that. And sorry, let me move that over. And the way they do that is they get you to do this in sort of simple steps. Okay? So let's work through this. Now, one way you can definitely do this problem is to look at similar triangles, right? So that triangle and that triangle are similar. Okay, so if you were doing this in high school, like I don't know, year 9 or something in Australia, you probably wouldn't use vectors. You would use similar triangles. Okay, but they want you to do this using vectors, I think. All right. So the notation that we're going to use is this. Oh, it's my crazy vector. Okay, so this is the question and the notation that they introduce. And so the first question is, if this is, say, the origin, get the position vector of M in terms of these vectors A, B, and C. Okay, so the easiest way to do that, in my opinion, is to draw a diagram. You want that vector there. Okay, so for part A, we want OM in terms of these position vectors A, B, and C. All right, so what I can do is say, okay, to get from the origin to M, first I can go from the origin to A, and then from A to M, right? So we know by the triangle law of addition, this is true. And I know what that is because it's up there. Okay, now AM. Can anyone tell me what the vector AM is in terms of the vector AB? Who can tell me on the chat? So if I want to write this vector AM in terms of AB, how can I do that? Jonah, yes. I would put capital A and capital B there, but yes, you're absolutely right. Okay, so OA is, plus 1/2 AB. Okay, now what is this? AB is the position vector of B minus the position vector of A. So let's switch this over now. So OA is little a plus. Okay, so let's do the algebra and simplify this. It's going to be 1/2 B, or A plus B, right? Ta-da! We did it. Okay, and the next thing they ask you for is this vector OP. That's the next part of this question. So you just repeat it, right? You would get OP in terms of OC plus CP, and then CP in terms of CB. Right. So part B is kind of the second part of this question is kind of the same. So OC plus CP, and that is this plus 1/2 of CB, and that is this, right, just in this notation up here. CB is OB minus OC. So again, that is just 1/2 B plus C. Okay, great. So what have we got? We've got OM equals that, OP equals that, right? So how does that help us show this? Well, let's put that together in the second part of this question. Okay, so we're wanting to show this. Let's write MP in terms of the position vectors OP and OM. Okay, so what is OP? OP is this. What is OM? OM is this. Okay, that's from part A. So what's going to happen? The B's are going to cancel out. You're going to get something like this. So what is the position vector of C minus the position vector of A? It is AC. So actually, we've shown more than this. We don't really, like, let me just touch that up a bit, because all this says is that the lengths, like one's a multiple of the other. We can actually go further and say, right, that's really what we're trying to show here. Let me move it over. Okay, so that's good, but actually this is even better. And that's what I have down here. Okay, so we will conclude that that is parallel to that, and this is half the length of that. All right. So I probably shouldn't have put those lengths in there. This is actually what you want. Okay. All right. I can zoom out a bit. There. All right. Questions. Questions. So this is probably a better starting point than this. Yes, man, good question. So if you look, let me go back to my big head for a second. Oh, hello. So, Meng, if you look at my algebra YouTube playlist, I do this question without the origin. Okay, so let me see if I can find that for you, and I'll show you where it is. So I'll just put the link in the chat, so you can do it without the you can do it without the origin. Okay, so I'll just put that in the chat. Okay, Alison, I can see your question too. So Meng, it's up to you. You know, if you want to use the origin, sometimes it's easy to do so. I'm just trying to work out which vector it is. Which video it is. Okay. I'm not quite sure, but have a look around. Okay. All right. So, Alison, how do you know to do? Oh, okay. Good question. So let's go back to the solution. Okay. So let me just share my window. All right. So remember, Alison, CB by the triangle rule is OB minus OC. So that is just B minus C, because OB is defined to be that, OC is defined to be that. Does that make sense, Alison? Because you wouldn't use B plus C because it doesn't, I mean, C, the vector from C to B isn't B plus C. Yeah. All right. Okay, well, there's some of the basic algebraic problems. I think what I might do, I might just pause the recording, and we can take, you know, just have a chat informally. Maybe there's things you want to discuss. You have some questions, other questions or something like that. So let me pause this, and we can have a bit more of a chat.